is similar to triangle DEF. What it clearly means that is that side AB over side DE is going to be equal to side BC over EF and it's also going to be equal to side AC over side DF. So it's very easy. Once they tell you that two triangles are similar, this is what the proportion gives you. Okay, so because these two triangles are similar, they usually what makes triangles similar, remember from your grade 9, either the sides make them similar or the angles make them similar. In this case, angle A, which is this one, is equal to angle D. Also, angle B is equal to angle E. And lastly, angle C is equal to angle F. So, usually with similarity, you can be asked to prove that if the angles in two different triangles are corresponding angles are equal, then the ratio will come out. So in other words, you can start with the angles and they want you to prove that the ratios are equal. Now let's now create some workspace. Let's have two triangles. The two triangles that we have, I'm going to make it slightly bigger. Yes, if this triangle here, and this is A, B, C, is similar to this triangle here, D, E, F. And in DF, this one has got one line, this one has got two lines. Now, if these two triangles are similar, and we are given that A is equal to D, B is equal to E, these are angles, and lastly angle C is equal to angle F. Then they say you are supposed to prove that, required to prove AB over DE is equal to BC over EF is equal to CA or AC over FD. So you want to prove that. So to prove that, we normally take two at a time. So now what I'm going to do is I'm going to say, okay, fine. I am going to construct. So the first thing I'm going to do is I'm going to construct the line inside this triangle. So the green one is the construction line, and I'm going to call it MN. And then construct MN such that now when I'm constructing my MN, I must make sure that AM is equal to DE. So this one must have the same. This one and this one must be the same. Can you see? And AN is equal to DF. So once I have constructed that, it means that I now have the smaller triangle inside the bigger one. Now, because they've told us that A is equal to D, and because the sides M and N, AM and AN are equal to DE and DF respectively, we can now go on and say triangle, therefore, after that construction, triangle AM N is congruent to triangle DEF. Why are we saying this? Because we said the two sides are equal, because AM is equal to DE and AN is equal to DF, and because we were given why, let's write down our reason. Our reason is AM is equal to DE, AN is equal to DF. That's construction. From our construction. And also A is equal to D. Angle A is equal to angle D. Given. So this is the reason is side angle side, because from the construction we got the sides and already A was given. Now once we say AMN is similar to DEF, it simply means that, therefore, implying that angle M is equal to angle E. Do you see that? The reason is, if this angle M is going to be equal to this angle here because of congruency. And then also angle N is equal to angle F, also because of congruency. But angle E is equal to angle B. Therefore, angle M is equal to angle B. Also, angle F is equal to angle C. Therefore, angle N is equal to angle C. Do you see that? Let me just write that clearly. Angle F is equal to angle C. Therefore, angle N is equal to angle C. Now, if angle M is equal to angle B, let's just look at our triangle, is equal to angle B, and angle N is equal to angle C, it would mean that, therefore, MN is parallel to BC. Why? Corresponding angles. Because of corresponding angles, M is equal to B, that would tell us that if those two are equal, then those two lines are also parallel. Once we have done that, we can now then use the proportional division theorem. Let's just take this triangle. Yes. To the next page. Now, if we now have that, it simply means that I can now use the proportional division theorem, and I'm comparing the triangle. It means that it means that AB over AM is equal to AC over AN. Do you see that? And the reason is MN is parallel to BC in triangle ABC. Now, remember our AM and our AN. If we go back, our AM is DE here, and our AN is DF. If we come here, we will say AB, therefore our AB is equal to DE. Is it DE? Let's just check. Yes, it's going to be DE. And the other side is AC over DF. And we have already proved one half of the similarity. You can also prove the other half by just taking that parallel line, constructing or using the third side. So similarly, this is what you would write. Similarly, if you can now then prove that AC is over DF is going to give us AC over DF is going to give us BC over is going to give us AB over DE. Do you see that? So now you can link all of them. No, it's not AB over D. Let's just go back. Yes, we need the third side. So we need this side. AC over BF DF is equal to BC over EF. So it's BC over BF. So you just write similarly and then you can continue. That's how we prove similarity. The way we use similarity usually it's in line with proportional division theorem, because that's what we use to prove similarity. So normally the questions for similarity are basically grade 9 type of question, and I wouldn't expect to see this one in the exam. So if triangles A, B, C are similar to D, E, F, then this is 5, this is 10, this is X, this is 100. So if I wanted to find X, I would say X over 100 is equal to 5 over 10, which means that X is equal to 5 times 100 over 10, which is equal to 50. That's how we prove, we use similarity.